Hi, students. It's Miss Murphy again, and we are continuing to learn about inequalities. Today, we're going to look at the pizza delivery activity in Desmos, and we are studying one variable inequalities. Okay, so we're going to go ahead and watch this. So, we're making pizza, then delivering the pizza in the video. That's what I seen, okay? So it takes 15 minutes to prepare and order and 3 minutes to drive each mile. How long would it take you to deliver each order? So if you're traveling, let's see, so it takes 15 minutes to start, but then you have to deliver it. 3 minutes, so that would be an extra, um, well, 3 times 2, that would be an extra 6. So it would take 21 minutes for if the distance was 2 miles. Okay, good. So we have some work here. If you notice the pattern, we always start with 15 and then we always multiply by 3 because it takes 3 minutes per mile. So that would give us 3x at the end of our expression. So always starting with 15, and then this other number is a multiple of 3 based on the distance. Looks good. Okay, it takes so we have our same story problem that we've been working with, but now we're looking at some inequalities, and it says um, you're a good business here with your pizza, and you want to promise your customers that you will deliver in 30 minutes or less. So let's really think about which one of these inequalities is the right um, one for this situation. So it's okay to if it takes exactly 30 minutes, that's okay, and it's also okay if it takes less than 30 minutes. So I'm going to focus on the top two because they have that equal to part. So it's okay if it's equal to 30. Now, if you take 45 minutes or an hour to deliver the pizza, that's too long. Your customers are not going to be happy. So we don't want this greater than symbol. We want things to be underneath the maximum. Describe all the distances they can deliver in 30 minutes or less. So which values of x will be included? So we basically have to solve this inequality. Um, I would describe this as, I guess, 15 subtracted on both sides. That would give us 15, and then divide by the 3. That would give us 5. So the answer is 5, but you keep the inequality symbol the same in your solution set. So as long as the person lives within 5 miles of the pizza store, then they can deliver. But otherwise, you live too far away, then they would take too long to get the pizza to you and it would be cold. So that's exactly what we just did here. We subtracted 15 on both sides, and then we divided by 3. We got 5. This other student chose to look at a table of values and chose the one that was maxed out at 30. Same answer both ways. Okay, let's talk about it again this time. So we have lots of toppings we could do. Now, Mariana, I guess I would say, can spend $20. That means she has $20 in her pocket. She doesn't have any more than $20. She can't go over budget because she wouldn't be able to afford it. She has to stay under her budget. So I'm going to focus on these bottom two because they're showing less than symbols. We cannot go over budget. They're not going to let you have a pizza if you don't have enough money to pay for it. Now she has $20. So do we need a 20 or do we need a 20x? Now, if there's a variable next to the number, that means it's repeating. That means you might have 2 or 3 or 4 $20 bills in your pocket. Now, Mariana only has one $20 bill. So let's say we cannot go over budget. Okay, what is a constraint? Well, a constraint limits things, okay? So um, Desmo's Pizza wants to deliver in 30 minutes or less. So that's a constraint. Mariana only has $20. That's a constraint. And we don't want to make more than 50 pizzas a day because we only have so many employees. So there are lots of constraints here. What's a constraint that you have in your life? Well, I would say like we can come up with our own example. And I'm going to put this one out here. Greater than or equal to 4. So this constraint, x is greater than or equal to 4. This example that I'm giving you is you should be spending 4 hours a day on your schoolwork for all your classes or more. If you're only doing 1 or 2 hours of school a day, then that's not enough. Okay. Jameer is planning to host a party at Trampoline World. So what constraints do you see here? Let's see. Well, the price is per hour. So one of the constraints you have is you would have to have the time that you rented out the facility be per hour. You can't go for like 5 or 10 minutes, or you would kind of waste your money on that. Um, there is a flat fee of $80. So and then it's additionally priced after that. So you would have to have a minimum of $80. So that would be a greater than or equal to $80. That's how much money you would have to have. Okay. And I don't know if we're going to have time to get to all of this, but we can wrap up on this page and kind of be done. So let's take a look here. We have some examples and then some solutions to choose from. So smart cost at most 140. What does it mean at most? That's the top end, 140, and we cannot go over. So that means it would look something like this, where we are less than or equal to 140. Now it does say small room here. So the small room is the $30 one. So there's our match. Okay, and this one here says the owner wants to earn at least $140, at least 140. So this is the lower boundary, 140. It's okay if you make more than that. So we're going to look at these two examples, and it's a large room, so we'll go with the 81. And over here we have up to 140. If you can spend up to 140, that's your top cap. It's okay if you are lower than that, but you're not going to go over 140. So we want to be less than or equal to 140, not over 140. So again, these symbols and understanding what they mean is super important. I'm not going to continue with any other pages in the lesson because we're just simply running out of time, but I really hope that helps you to complete the pizza delivery activity and understand inequalities a bit more than what you did prior.